Well, hello Internet, and welcome to my Ruby programming tutorial. In this one tutorial, I'm going to cover pretty much 95% of the Ruby programming language, all of the basic syntax. And Ruby is basically a dynamic, interpreted, object-oriented language in which everything is an object, and all of those objects can be overwritten. Ruby is one of the easiest languages to read and learn, and with Rails, it just might be the best web development option, period. In the description underneath this video, you will find easy links to all the individual pieces of the Ruby programming language that I cover, as well as a link to all of the code that is heavily commented and easily transcribed. Well, enough talking, let's start writing some code. Okay, on the left side of the screen, I have a basic text editor, which is called Sublime Text. I'm trying a different color option here, so if you guys like it, please tell me in the comments section below. And on the right side of the screen, I have the terminal, or command line if you are on Windows. And if you want to install Ruby, I'm not going to go through that. It's very easy. Just go to ruby-lang.org and then whatever, and installation. And here you'll find all of the information you need, as well as easy installers depending upon what operating system you're using. Alright, so in this first part, I'm just going to briefly cover a whole bunch of different things. If you want to put a comment in, just put a hash symbol, and that is a comment. I'm going to go over other different comments as well as we continue. If you want to print something to the screen, very easy to do. You could say something like enter a value, like that. And then variables are either going to start with lowercase letters or an underscore, normally lowercase letters, and of course after the underscore or lowercase letters, you're then going to be allowed to use numbers in your variable names. Let's say I just go and create. The normal way of creating variables is to use dashes between or underscores between all the different words in your variable names. And if I want to get data from the user, I just type in gets, and then if I want to convert that from a string to an integer, I would just put .to_i. I could then ask them for another value, enter another value, and then get that one as well using gets once again, and it's very important to convert it to an integer. Then another way we can output data is using puts, and the difference between print and puts is print will not put a new line after it prints out your string that on the screen, while puts will put a new line. And let's say that we wanted to say something like first number. We want to convert this back to a string. To do so, just put to_s. If you want to concatenate or combine strings, you just put the plus sign, and I could put something like plus like this, and then continue on with second number, to_s plus equal to, and you can see I'm just continuing to add these together. You can skip over to the next line, and of course you do not need to put a semicolon at the end of every statement. And then if I wanted to actually perform some arithmetic inside of here, I could do so, and then I would just convert that to a string. And if we come over here, and you can see the name of my file is Ruby or not Ruby, and I'm just going to type in Ruby to execute it, followed by the RB extension, which is the extension for all Ruby files. If I execute it, you can see enter a value. I can type in 2, enter another value 3, and there you can see the answer pops up on the screen. Now there are 5 main arithmetic operators, and we can of course have addition, subtraction, multiplication, division, and modulus, which returns the remainder of a division. You can see over here, if I enter those in, you can see the answers that show up there on the screen. Now integers or fixed numbers can store extremely large numbers that do not have decimal places, and you can pretty much trust that an integer can hold well beyond the number that I displayed here on the screen. So they are quite large. And Ruby uses a different way of storing integers that allows you to basically be able to store numbers that are that large. Now let's say I come in here and let's create another integer just to show you an example of the accuracy of floats. And this is a float. Let's just say it's 1.000. And then let's store another float inside of here. And one thing to remember about floats is there must always be a number before the decimal place whenever you define them. And then we could come in here and just go num1 and convert that to a string plus, here let's do some subtraction this time, num99, again convert it into a string, plus num1 minus num99, string, save it. And if we execute it, you can see that it is quite accurate up until it gets to the very end of this float where it has that 9. Basically with floats, you can trust that 14 digits of accuracy is a basic norm. So let's come in here and create a big float, and there you go. And then let's perform a little bit of arithmetic here. Now a big float plus Remember, always put the 0 there. And you can see that while it will be able to store up to 14 digits of accuracy if we try to perform a calculation like this, that it is not so accurate in performing that calculation. So just like every other programming language, float arithmetic is a little bit off, so you should be aware of that. Now, I said before that every single thing inside of Ruby is an object, and let's just prove that. If we come in here and type in one.class, which is going to return the class of whatever precedes it. We could even put a float inside here, .class, and of course we could come in and put a string inside of here, .class. And if we execute that, you're going to see that this comes back as a fixed number, float, and string. And we'll get more examples of exactly what a object is inside of Ruby. Basically everything. Now, a constant's going to start with an uppercase letter, so we could put something like a constant like that, and 3.14. However, you have to be aware that while we will say this is a constant, that doesn't mean we can't come in and also change the value. What's going to happen, though, whenever we run this and we try to change the value for the constant, we're going to get an error, but it still will allow us to change it anyway. As you can see right there, there is your warning, However, the constant value did indeed change. And then just to show you one more advanced thing, let's say that we want to return a file object. It's quite easy to do. Go write handler, and we would use the file object. I'll do a more advanced tutorial on this later on at the end of this tutorial. But let's say we have a file called your sum we want to write to, and we'll just give this the out extension, and then say that we want to write to it. That's going to create the file, by the way, if it doesn't already exist. We could then very easily come in and put some text into that file. Let's say we wanted to put random text, and you could put variables, you could put pretty much anything you want inside of there, but you do need to convert it into a string. We would then come in here and close the file after we are done with it. And then if we wanted to read data from the file, data from file, is equal to, we would just use the file object again and say read, and then say what you wanted to read from. Say it's called your sum.out, and then put the data on the screen. We could do that just that easily. And as you can see, data from file is random text. Just that easily, we were creating a file, wrote to it, closed it, reopened it, read from it, and now put the data on the screen. And then finally, if you wanted to also come in here and load and execute code in another Ruby file, let's say we have one called Ruby or not Ruby.rb. And let's say give that 2 as a value. We could then come over here and create Ruby or not Ruby 2 and just say hello from Ruby or not Ruby 2. Save that and then jump back over here. And there that is. File save and execute. And you can see that that is how easy it is to execute code from other different files. Now let's get into performing some conditional operations. Another thing to remember though, first off, is if you want to have a multi-line comment, all you would do is equal begin, multi-line comment, and then equals end. That is a weird way of doing a multi-line comment, but that is how they are created in Ruby. Now let's get into conditional operations. Let's say we have a variable called age, and let's give it the value of 12. We could come in here now and use if statements to compare values. So we could say something like if age is greater than or equal to 5. We can also use logical operators like and, or not. And then we can go age is less than or equal to 6. We could then come in here, don't need the curly braces you might be used to. Say something like you're in kindergarten, like that. We could then come in and go else if age is greater than or equal to 7 and age is less than or equal to 13, and I'll put some different data. You are in middle school. Something else that's important is we're going to be able to put multiple different statements in here. So we could say yay, and then we could say something like else puts stay home. And it's very important to end your if statement with the term end or the keyword end. If we execute that, you're in middle school, yay shows up here on our screen. Now it's very important to know there are a couple different comparison operators. So the comparison operators are going to be equal to, not equal to, less than, greater than, less than or equal to, as well as greater than or equal to. And then your logical operators, which you're going to be able to use to combine and differentiate those different comparisons, is going to include and, or, and not. And you could also type and, or not inside of there if you decided that that would be something you'd rather do. And just to give you a demonstration of those, let's say we have true and false is equal to plus true and false dot toString. And let's do the same thing for your other logical operators. So here is or, and or, and then not, let's just say not like that, and then not like that, which is going to return the opposite. And there you can see exactly how those logical operators work. Another comparison operator you have available to you, say we'd go puts, and we wanted to do a comparison. It's going to provide different answers depending upon how the logic works out for that comparison. We have this little guy right here, and basically what it's going to do is it's going to return 0 if both of those values are equal, 1 if the first is greater, and -1 if the first is less than the other one. If we want to perform this operation just to see how this works out, 10 to string, and there you can see it shot back -1. And the reason why is the first is less than the other one. Just going to give you a rundown of all the different ways to compare just for completion reasons. Unless is another comparison operator, and it just goes unless age is greater than 4, puts, you could say no school, else puts go to school. And then once again you would put end, and you can see go to school comes up here. And the reason why is this is only going to execute this line right here if age is less than 4. So that's how unless works. There's a bunch of different ways to do comparisons inside of Ruby. You're also going to be able to come in here and add conditions to the output. So we could say you are young is going to execute if age is less than 30. And you can see that it did. Another way of comparing things is using the case statement. So we could say something like print enter greeting, go and get that greeting from the user, equal to gets, and then we could put chomp on the end of here if we wanted to remove the new line that goes with the input, because the person types the input and then hits new line or enter, and that's what chomp does, gets rid of that new line. We could then create a case statement that says greeting, and then say when what they type in is equal to French. We could also come in here and put multiple different stipulations so they can use lowercase or uppercase. Well, then we're going to say bonjour. Once again, when they type in Spanish or lowercase Spanish, we could say hola, like that, and make sure that is exit and not end, exit. There you go. And then finally, we could type in else, and this would substitute as the default, and we'll just put English inside of here. And then we could put puts hello. And then the end is actually the ending for the case. Execute, and we could just say nothing, and it's going to say hello. And we could come in here and say Spanish, and it's going to go hola. And we could also come in here and get that English and remove that altogether, and you're going to get exactly the same results. Spanish. There you go. Another conditional we can use is what is called the ternary operator, and basically it is going to provide different input depending upon a condition. So we could say if the age is greater than or equal to 50, for example, and then we put a question mark, it is going to return old as the output or the assignment if the condition is true. Otherwise, it's going to return young if the condition is false. And there you can see young shows up. Now let's get into looping. This first loop we're going to demonstrate, we're going to create a variable, give it a value of 1, and then we're just going to type in loop do. We could then come in here and go x plus or equal to 1, which is going to be the shortcut for x is equal to x plus 1. Same exact thing, both of these guys right here. And you can also put comments right there in the same statement, of course. And let's say that we wanted to come in here and only print out on the screen even numbers. We could then type in next, unless x modulus 2 is equal to 0. And next, what it's going to do is jump back here to the top of the loop and continue iterating through the loop. Otherwise, if we do have an even number, let's print that out on the screen. And then let's also use break, which is going to throw us completely out of the loop if x is greater than or equal to 10. And that's going to stop our looping. And with the loop, you're going to also type in end. You're going to do that a lot of times. And if we execute that, you're going to see it prints out 2, 4, 6, 8, and 10. So next, if it gets down here, it's going to add the value of 1 to this, which is going to be 2. And in that situation, since 2 is an even number, it's going to print it out on the screen. And then it's going to continue. It's going to check, is it greater than or equal to 10? No. It's going to jump back to the top of the loop. It's again going to add 1. This time we're going to have 3. It's going to say, does this equal 0? Well, the modulus of 3 and 2 is going to kick back 1. So it's going to say that that indeed is true. So it's going to execute next, which is going to jump back up to the loop again. It's going to add 1 to it, and you're going to get a 4 and continue onward and onwards. And then break, of course, like I said before, whenever this condition is met and comes back with a true, it's going to continue execution after the loop and end the loop altogether. Let's go in here and create ourselves another variable to show you exactly how while loops work inside of Ruby. Let's give this a value of 1. We could then come in and go while y is less than or equal to 10. and then we could increment the value of y by 1. We could then do exactly the same thing. We'll say next, unless y modulus 2 is equal to 0. Print out on our screen again the value of y if it's an even number, and we could also put break inside of here and say if y is greater than or equal to 10, we can kick ourselves out. But the while loop's going to kick us out anyway because that's already there. So we can get rid of this altogether. And of course, we're going to end the while loop with end as well. And if we execute that, you're going to see 2, 4, 6, 8, and 10 print out on the screen again. Told you there was a bunch of different ways to loop and use conditionals inside of here. Let's come up and let's create another variable. And this time we're going to cover the until loop, which is just a different way of doing things. Basically, it's going to do stuff until a condition is met versus end when a condition is met, like the while loop works. And to use it, you just go until a is greater than or equal to 10, and then we're going to increment the value of a is equal to 1, and we're going to come in here. Then we could also put next inside of here if we'd like, so that we can print our odd and even numbers. 2 is equal to 0. And then in that situation, we could print out on the screen the value. And again, until ends whenever end is typed in or reached in execution. There you can see is another way to print out even numbers between 2 and 10. There's actually a couple different ways to use for loops. All these are sort of considered for loops. We could create here an array, and I'll get more into arrays later on. It's just basically a box that contains a bunch of different values in memory. So there's numbers. We could come in and go for number in numbers, and in this situation it's going to be cycling through this numbers array, and each one of them as we cycle through is temporarily going to be stored in a variable called number. We could then output them by going puts, and if you want to have the value of a variable show up inside of a string, you put the hash symbol right like that, and we could go number like this. We could also throw a comma inside of there and a space if we'd like, and this also ends with end, and there you can see it cycles through all those and puts commas there on the screen. We could also come in here and go print like this, and that time you can see that there is no new line. We could also come in here and define an array called groceries, just to show that you can cycle through pretty much anything. Let's say we have bananas, sweet potatoes, pasta, and tomatoes. There you go. That's our groceries array. We could cycle through all of these by going groceries. Each, do, you're going to put or, food. Food in this situation is going to be the temporary holding cell for each item inside of our groceries array as it cycles through these. And you go puts, get, some, and then if we want to go and put the value for food inside of there, there we go. And of course, end this with end as well. Whole bunch of different ways of iterating. Get some bananas, sweet potatoes, pasta, and tomatoes. That all prints out. We could also cycle through numbers, and this is very simple. Let's just say we want to cycle through the numbers 0 through 5. This is called a range, which we'll cover more later on. And then we could go each, do, again, or is going to be the temporary value as we're cycling through. And then we could go puts, hash symbol, and then we could put I inside of here. And let's put another hash symbol here, but this is going to actually be a hash, and there that is. And again, that's going to end with end. Execute, and there you can see all of those printed out. So there's pretty much every way we can both use conditionals as well as looping. Now let's take a look at functions. Now functions are going to start off with def, and then you're going to have your function name. So let's say add nums. Then you're going to have parameters, if any, inside of here. So we'll say num1 and num2. And then you can either return a value or not return a value. So I'm going to say num1, and I'm going to convert this into an integer, and then num2, and convert that into an integer, and then it's going to return that value. And functions also end with end. We could then come in and go puts, add nums, and pass 3 and 4 into there, and execute that. You can see 7 shows up on the screen. Now it's very important to understand when you're dealing with functions that variables are passed by value, so their value can't be changed inside of a function. So yeah, that's true even if you have the same name. So let's have x is equal to 1, and then we'll create a function and change that, and we will pass supposedly x inside of it. Then we'll go and give x the value of 4 inside of the function. We will then call change x, and we will pass x, but this is this x here we're passing. Doesn't have anything to do with that. And you're going to see here if we go puts x is equal to dot, and then we'll put the hash symbol inside of here and x, and execute it, it's going to print out 1. So any value that changes inside of a function is not going to affect an outside value. And this is very important to remember whenever you're working with functions. We'll get more into functions later on, but that's the basic gist of how they work. So now let's take a look at exceptions. Now, exceptions inside of Ruby go by different names. We're going to be able to catch exceptions in Ruby using both begin and rescue. So we're going to say print, enter a number, and once again we're going to get that value and store it in a variable called first num, and we'll use gets and then convert it from a string into an integer. And we'll then say that we want to enter another number, and we'll store this in a variable called second num, and we'll use gets again. Now, if we think we might have an error, we're going to put begin, and then we're going to put some code inside of here that might throw an error. So we're going to say answer is equal to first num divided by second num. Then after that, we're going to type in rescue, which is going to be called if there's an error. And here we're expecting the error to be a division by 0. So we're going to say you can't divide by 0. And then we'll put an end, which is actually going to end the begin. And also we could come in here and throw exit. Now if we would come in and go puts first num divided by second num is equal to, and then put answer inside of here. And make sure you put a closing brace right there as well. And execute it. Let's put 3 inside of here and then put 0. And you're going to see you can't divide by 0 shows up. However, if we would go and do something logical like 4 and 2 and 3, whatever, it doesn't matter. You can see that it does indeed work. You can also throw your own exceptions with raise. So let's just come in here and delete all this and create a function called check age and pass age inside of here and give age a value of equal to 12. We could then say raise argument error, and we could say enter a positive number is going to show up unless age is greater than 0. We're going to end that function right there, and then we're going to also catch this potential error with rescue. So we could say begin, and then we could go check age, and let's pass -1 inside of there. Let's just ignore the age part there, and then we'll be able to come in here, let's indent that, and say that we specifically want to catch an argument error, and if it is triggered, we're going to print out that is an impossible age, and then end that. And you can see if it executes, that is an impossible age prints out. There's a whole bunch of different ways to use exceptions inside of Ruby. Now, we've been doing a lot of things with strings here, but let's look specifically at some string functions and a whole bunch of other different things. Basically, strings are just a series of characters either between double quotes or single quotes. For the most part, you're going to use double quotes though. So let's just come in here and go puts, add them. And one thing that's important that I didn't cover is if we put a hash symbol in here, we'll also be able to do things like perform addition inside of here, a whole bunch of other different things, not just variable names. And then we could throw some backslashes inside of here. And let's look at the difference between if we would use double quotes versus single quotes here. We can put a single quote there and a single quote there. Execute that, and you're going to see here that the new lines indeed do work whenever you use double quotes, as well as this interpolation, which is right here. That's what that's called if you want to know the technical term. And whenever you use single quotes, those do not work. So something that's important to remember, and another reason why we barely ever use single quotes with strings. A here doc is normally used whenever you want to use a multi-line string and you want to continue using all of the new lines and things. So let's just say multi-line string, and how this would be created is you'd put these two caret symbols here, EOM, and then you could go something like this is a very long string that contains interpolation, like, and then you put a hash symbol inside of there and say something like 4 + 5 just to do that, and then put some new lines inside of here just to prove that the new lines work, and then you would end this multi-line string with the EOM at the end. You could then come in and print that out, multi-line string, and execute, and there it is. You can see all of those different lines and how they kept the new lines and everything all in order with that multi-line string. Let's go and create a couple different strings here. We can say first name is equal to Derek and last name is equal to Banis. You can combine or concatenate strings by using a plus sign. So we could go full name is equal to and first name plus last name. I could go in here and create another one, say middle name is equal to Justin. You could also combine strings with interpolation. So we could say full name is equal to hash symbol and first name and middle name and then last name. There we are. We could also come in here and check if a string contains a string, and let's just use puts here, and we could go full name, and then we would say include with a question mark and what you're looking for inside of that string. And then we got a little bit of an error. Let's just throw an underscore inside of there. There we are. And there you can see true came back for that function. And we could also get the number of characters that are inside of that string. There's 18. Do all kinds of things. Let's say that we wanted to count the number of vowels inside of here. So we could just go vowels and then go full name dot count, and everything you put inside of here is going to count, or it's going to find all of them. So A-E-I-O-U, and let's convert that to a string. We could also do the same thing to find all the consonants. So let's throw that there, consonants. And if we want to find the opposite of what we're searching for, so anything except what we have listed here, we're just going to put in a caret symbol like that. We could check that a string starts with another string. Puts full name, start with, and then we could throw in my last name. We could also come in and get the index inside of here, or the character number inside of here for a match. So we'll go full name again, and index, and then what we're searching for specifically. Convert that to a string, and there you can see all of those printed out for us. So there's a ton of different functions inside of here. We could also come in and check for equality. So let's go and just delete this. Puts, so if we want to check A equal to A, and then we can go A equal to A. You can see that comes back as true. We could also perform a check to see if something is exactly the same object. So puts, if we wanted to use a double quote inside of here, we'd have to backslash that double quote like that. And then we could put A, and then let's backslash the double quote. That allows it to be contained inside of double quotes. And then equal question mark, backslash double quote, A, backslash double quote. And then let's concatenate that, and then let's actually do an operation. So we'll go A, and then equal, A again, and toString. And there you can see that they show up as false. However, if we went in and typed in puts and say first name dot equal, and then first name inside of there, in that situation it's going back with a value of true because they are the same exact object. We could also uppercase every single thing, so just type in uppercase. We could lowercase everything, and then there's also swap case. You can see exactly what those do. There you go. Let's say that we then went into our full name and we just put in a whole bunch of spaces inside of here for no good reason except that we want to show exactly how to eliminate that white space. So full name again. We could then strip off all the left white space by going full name equal to full name dot L strip, and we would be able to also delete any white space on the right by changing this to R strip, or we could delete all the white space altogether by just making that strip. And just to do a little bit more of a completionist type of thing, why don't we cover formatting strings? We could also go puts, full name, R, justification, and this is going to give us 20 spaces. Then full name plus everything else is going to come out to 20 spaces, and let's say any additional spaces we have of those 20, we want to put dots inside of there. We could do that, and that's going to be right justified. We'd also be able to do left justified as well as center. And it's easier just to show you exactly what this looks like rather than trying to explain it. And there you can see. Here we have right justified, here we have left justified, and here we have center. We could also chop off the last character by just typing in chop. And we could also come in and use chomp, which we covered previously. By default, it's going to eliminate a new line if it exists. And if there is no new line, it's going to do nothing. And if we wanted to delete the last two characters, for example, we would actually put whatever specifically we wanted eliminated. And there you can see, chop just cut off the last letter right there, and chomp cut off both of the letters that we defined right there. Give ourselves a little bit more room here. You could also have it delete specific characters that you'd like deleted. So let's just go full name, delete, and it's going to delete every occurrence of A in that situation. And we'd also be able to go and create an array from a string by just going full name and calling split. And in this situation, we're just going to put two symbols there, which basically means it's going to just split everywhere there is a new character, or you can split everywhere there is a space, for example. And let's just copy this, and the difference you're going to see here in a moment. Here we're going to put a space inside of here. You could also put a comma inside of there if you'd like. And if we execute, this is the one where it's just going to show each individual part of the string in separate parts of the array. Get more into arrays here in a second. And then here you can see it split everything based off of spaces, and up here you can see that it eliminated all the A's that we also covered. And just to reiterate this a little bit, You're going to be able to perform string conversions. If you want to convert a string into an integer, you would just put 2 underscore I. If you wanted to convert it into a float, 2 underscore F. And if you wanted to convert it into a symbol, which we'll talk about in a little bit later, 2 underscore symbol. And then finally, if you'd like to see the most common backslashes you're going to be able to use, there they are. Okay, so if everything's an object inside of a Ruby, we might as well talk about objects. Now, in object-oriented language, we basically are going to model real-world objects using classes, and just like everyday objects, every object is going to have attributes, which we are going to call instance variables, as well as capabilities, which we are going to call methods. Now, let's say that we have a class called animal. Inside of it, you can put an initialize function, and this is going to be called anytime a new animal object is going to be created, and this is where you would normally put default values. Here we're just going to say creating a new animal, and then end that, of course. I'm going to show you really easy ways to create setters and getters inside of Ruby, but for now I'm just going to create a setter and getter. Let's say it gets passed a new name. If you wanted to set an instance variable inside of Ruby, you would put the @ symbol, and then name. Don't need to do anything else with it. And this is going to assign that value like that. And of course, we're going to want to put end there as well. We could then define a getter, and you just put @name, and that's going to automatically return that, and put end. Another way you could come in here and get a value is def name, and then just put name inside there like that. And another way you could provide a setter is go def name equal to new underscore name. And one of the reasons we use getters and setters is to make sure that bad data never gets in. So let's say we want to make sure that the name that is passed in is not a numeric number. We want to make sure we're using characters here. Well, we could just go numeric like that. And if it is a numeric, we're going to say name can't be a number, something like that. Else, we're then going to assign the value that was passed in there to our name instance variable. And here we will end the if, and here we will end the setter method. And then finally, we're going to end our class. So that's how that all structures out. Now, after we've created this class, we'll be able to come in here and create animal objects. So let's say we want to create an object called cat. We would just call animal and new, and that's going to create that animal object. We could then go cat set name and pass in a name for it. We could then get the name of it, cat get name. The alternative way of getting name would just be cat and then just typing in name, which is normally what you would use. Like I said, I'm going to show you a shortcut for generating getters and setters in a second. And then an alternative way of actually setting the name, just be this, and then let's say we want to type in this new name, puts cat name again. And there you can see creating a new animal, and that's the initialize function. It's going to be called every single time a new animal is created. And then you can see all the different ways that we are using to set the name and get the name and exactly how they work. Pretty much exactly the same. When I go and create the new and improved dog class, and here I'll show you the shortcut for creating all your getter functions. You're never going to type this in though, because I'm going to show you a way to generate them all. Name in this situation is a symbol, which like I said we'll talk about a little bit later on. And let's say you wanted to also have a weight instance variable inside of here. Those are going to create all of your getter functions automatically. If you wanted to create all of your setter functions, you just again list all these different instance variables that you want to have. And there you go. Or you could create all your getters and setters with one statement by just typing attr accessor, which is normally what you're going to do. And then type in your instance variables again and wait. There you go. Now we could come in here and define another function called bark, which is just going to return a generic bark, and close that, and then close your class. Now we could create a dog object like that. Move that up so we can see it all at one place. We could then go rover name just to prove that we have our getters and setters. Let's just call him rover. Output rover on the screen with rover name. And there you can see rover prints out on the screen just like we set it. Now whenever we inherit from another class, you get all of the methods as well as instance variables automatically. So let's go and create another class, and we'll call this German Shepherd. And how you inherit from dog in this situation is just putting that caret symbol in there with dog. And of course you would be able to come in here and inherit everything but also overwrite. So let's say you wanted to have loud bark print out instead of generic bark. There you could do that. And then close off your class. And everything automatically goes through. Let's say we create a German Shepherd called Max. German Shepherd, there he is. Again, type new, and you'll be able to come in here and define name, even though you didn't define it inside of the German Shepherd class, because it was inherited. And when we talk about printf, printf is going to be able to do some formatted printing for us. So let's say we want our strings inside here. Strings is going to be %sign and s. Then we can go goes %sign s, and then we want to throw a new line inside of there. We would then be able to go max name and max bark. And if we execute it, you can see everything works out. Now let's talk about modules. Modules are made up of methods and instance variables just like classes, but they can't be instantiated, which means you can't turn them into an object we can use. Most common reason you're going to use these is to add functionality to a class, because we're only going to be able to inherit one class when we're creating a class, but we will be able to inherit multiple modules. Let's start off by creating a couple modules here. We're going to create one called human, and how we create a module is just go module, and I'm going to call this human. Remember, if we want to automatically have our getters and setters set up for us, accessor, there we go. And then let's say we have name, height, and weight. There we go. We could then define a function inside of it, and if we wanted to output a specific name for our specific object, we'd use self, just like you use this in many other programming languages. And then we could just have the name show up there and runs. Close that off, and just like everything else to close off the module, we put an end there. And I'm going to call this human RB is the name. Save it, and let's go and create another one. This module is going to be called smart. Then we'll put a function called ActSmart inside of it, and whenever that's called, it's going to return E equals MC squared, for example. And we'll close that off, and we'll close off our module, and we're just going to call this SmartRB. Save it. Now let's jump back over into our regular class we've been using here, or regular file. Now if we want to allow access to those modules, we're going to have to go require relative at the top of our file here, and then type in what we want, and it has to be in the same directory, of course. Relative again, and we're also going to put smart inside of here. We could then create another module, just to create a whole bunch of modules, and this one's going to have a function called make sound, and whenever it's called, it is just going to print out grr on the screen, and that. This is just to show you can have modules in different places, but you normally want them in separate files. It's just easier to work with. We would then be able to create a dog class inside of here, and if we want to include that module, we just go include animal and end, and you'll see here we can go rover is equal to create a new dog object like that, and then rover, and we could say make sound, and there you can see grr prints out on the screen. We could also create a class called scientist, and we could include our human module inside of here just by going include human. We could also include our smart module inside of here, and if you want your module to supersede so that if a function is in both this class as well as the module you are taking it from, you would use prepend instead of include. And we'll go smart here, and then what we're going to do is we're going to define a function called ActSmart, but remember our function in smart is going to supersede this one even though we created it inside of here because we used prepend instead of include. And in this one we'll put a different version, MC, let's say squared, like that, just so you can see it. And then we'll close off our class again. Now you can see if we create Einstein is equal to scientist dot new, and we go and create a name for him and make that name is equal to Albert, like that. We can print that out, Einstein, just like that. And we could also go Einstein, call the run function inside of the human just to show that that works, and then go Einstein name says Einstein dot ActSmart, save that and execute, and you can see right here E equals MC squared shows up instead of this, and the reason why is we use prepend right there, and if you look up here you can see the version that actually prints out on the screen. That's a way of using modules and classes and objects and a whole bunch of other different things. Something else that no doubt will come up, people will think about, is polymorphism. It works a little bit different inside of Ruby. Let's say we have a class called bird, and it has a tweet method, tweet. What we would do here is, so that you know, statically typed languages use something called duck typing to achieve a version of polymorphism. And the reason why they do that is languages like Ruby pay less attention to the class type versus the methods that can actually be called from an object. So let's say we have bird and tweet, just like we said. What we would do here is have bird type, and we would call tweet on that. So the actual object that's being passed in here, we would then call its specific version of tweet. You're going to see here in a second what that looks like. So we'll go end and end this class as well. Then we're going to create something else, another object called cardinal, or another class anyway. It's going to inherit from bird. And then we're going to put tweet inside of it as well. So in this situation, we're going to go and print tweet out on the screen when that's called. And then let's create another one, another class called parrot. Also going to inherit from the bird class. It's also going to have its own version of tweet. Make sure that's lowercase. Puts, and whenever it's called, it's going to squawk. There we are. Now we can create a generic bird, which is going to be of bird type. And what we'll be able to do to simulate the polymorphism is call tweet and then pass in a cardinal in this situation. And new, you can go and create the cardinal object outside of here, of course. And then we'll go tweet, and then in this situation we'll call parrot new. And if we execute that, you're going to see the tweet prints out for our cardinal, which we have right here, while squawk prints out for the parrot right there. So there's an example of duck typing and polymorphism inside of Ruby. Now I'm just going to briefly cover symbols. Now symbols inside of Ruby are basically strings that cannot be changed. And you're normally going to use them to either conserve memory or to speed string comparison. And you would usually use a symbol versus a string whenever you need a string that's value doesn't need to change, as well as you need a string in which you do not need access to string methods. They're very commonly used in hashes for keys and so forth. Again, we're going to get into hashes in a second. Symbol basically looks like this, and its value is whatever it is right there. Now let's just go and print it out on the screen just so you can sort of see this. So let's go puts and Dirk, and then puts, print a couple of these guys in here, 5 of those, and also let's convert it to a string just to see what it looks like. And if we come over here and execute, you're going to see Derek symbol, which is the class type, shows up there, as well as a unique object ID. And like I said, we're going to get more into those as time goes by. But you may also remember a symbol here, which you used previously, in which we automatically generated our getters and setters inside of our function. Looked like that, remember? I want to type in wait as well. Symbols are used a lot inside of Ruby, and like I said before, they're very often used as keys inside of hashes. Since we mentioned hashes, why don't we talk about something that's very similar first, called an array. Well, we have already seen arrays. Let's go and create a couple arrays here. A couple different ways you can create an array. You could call array new, like that. You could create a different array by going array.new and then saying that we want 5 spaces in our array, or 5 little slots where we can put stuff. In that situation, the default value is going to be nil, which means pretty much not a value. And we could create an array also by going array new and saying that we want 5 spaces set aside, and the default value in this situation would be empty. And we could also go create an array by actually passing values, and you can store anything in an array. You can store 1, you can put a string inside of there if you'd like. There's 3, or you could put a float inside of there. It's not going to bother anything. And let's say we want to come in here and print these out on the screen just to see what they look like. There you go. There's empty, empty, empty. This is actually where we have nil, which is not a value, and here we have empty, and here you can see that we printed out all the different values that we stored in our 4th array. Now with arrays, they are going to start off storing things in an index of 0, which is very common. So if we just typed in 2 here, you can see that 3 shows up, but that's 0, 1, 2. That's how we're going to get all those different values inside of our array. We would also be able to come in and return 2 values starting at the 2nd index, for example, by just putting 2 and 2 right there. And I'm going to put join inside of here, so we'll join all of our results together and separate them with a comma and a space. And there you can see that's how that worked out. We could also come and return values by doing values underscore at, and then inside of here we could list we want the 0 index, the 1 index, and the 3, for example. And once again, we're going to join those together with a comma and a space. and put a dot inside of there because that is a method. Execute, and there you can see it returned those nicely for us. We would also be able to come in here and add a value to the beginning of an array by using unshift, and then whatever value we want to put in there. Let's say we want to put 0 inside of there. We could also go and remove the first item in an array by going shift, and then there's not going to be anything because it's just removing an item. We could add 100 and 200, for example, to the end of an array by just going push, and play around with these on your own to see exactly how they work. And that's going to add 2 values to the end, while if we would go in and type in pop, that's going to remove 1 item from the end of our array. We could also come in here and concatenate or join 2 arrays. We could create a brand new array here if we'd like. So we could say we wanted to put 10, 20, and 30. That's going to add that to the very end of our array. And there's a whole bunch of different methods we could use. If we wanted to get the size, array4, and type in size, put our braces there, and let's say we want to convert that to a string. There you go, array size is equal to 8. We could also check that an array contained a value, so it contains 100, for example. And here, instead of size, we're going to put include and a question mark, and then whatever you're searching for, 100, for example. We could check how many of those matches we have, so how many 100s, for example, and then take the size out of here and instead put count inside of there and specifically what we're looking for. And we could also check to see if the array is empty by just going that, and then we're going to type in empty question mark, convert that to a string, and there you can see all those come back. We could, of course, just like I showed you with join before, convert our array into a string, puts array4 dot join, and then however you want those combined into your string. P is pretty cool because it's going to allow us to print out the entire array on the screen in just one way, which is kind of neat. And we could also print out our whole entire array in a loop situation by putting each inside of there. And we saw this before. At symbol, let's say we want each of these individual values in our array to temporarily be stored in a variable called value. And then we could go puts and value as it's shooting through there, and then end that. And if we execute, all those things show up right there on our screen. So pretty cool. So that's pretty much everything you'd want to know about using arrays. Why don't we look at a close cousin to array called hashes. And a hash is just a collection of key-valued pairs. So let's go and create ourselves a number hash, for example. We would use curly braces in this situation. And first you're going to have your key. Instead of indexes, you have keys. And then you're going to put that little symbol right there, and then whatever you want the value to be associated with that. And then you can put a comma, and then let's go and say we want another one to be called golden. Put that little symbol there, 1.618. And then let's say we want another one to be E, little symbol, 2.718. And that is how you create a hash inside of Ruby. Now let's go and use them. We could go puts to get the actual value, number hash, and let's just pass in, well, make sure you put square brackets here, square brackets, and whatever the key is, and that's going to print that out on the screen for you. So we're just using keys instead of indexes, which are sometimes easier to use. Say we want to create a superhero type of hash, and of course you could have these all be on separate lines just so they show up easier on your screen. There you go, like that, do whatever you want. And of course you're going to be able to call superheroes again and pass in Clark Kent, for example. Make sure you have the key exactly the same though, and there that shows up as Superman. You'll be able to come in and add an individual new key and value to your hash by just going superheroes and then defining whatever you want the key to be, right like that, and automatically going in and adding in a new value for that key. There it is, it's in there now. Something else is you could add a default key value, which is very useful, so that if the user goes and looks for something that doesn't exist inside of your hash, it's going to print out something useful like no such key if it can't find anything, which is, like I said, pretty useful. Let's say you go in here and say I want to get whatever is in sample hash with the key dog. Dog doesn't exist, and you see no such key comes up. We could then come in and create some super heroines hashes right like this. You could then combine these with update by just putting in superheroines instead. And whenever you're using update, this is considered a destructive merge, which means if there's any duplicates, they're going to be eliminated. You could instead use merge, which would be a non-destructive, which would keep all the keys and values even if they matched. Normally you're going to use update because you wouldn't want any duplication inside your hash. That would just cause confusion. And then if you wanted to go through exactly how to print all of these out, we would just go superheroes, and we would use each again, do. You could get the keys and values by just putting in key and value, and then close that. and then we'll go puts, and then we go key, and we need to convert that to a string, plus, put some separation between these, and a value, and end, execute. You can see all of them printed out real nice. And of course, there's a whole bunch of different functions available for hashes as well. We could come in here and check that our superhero's hash has the key of Lisa Morrill like this. Also be able to come in and check if we have a value by passing in a value. So there's Batman, and you can see right there is Batman. This is the key, that's the value. And of course we could check if it's empty, as well as whatever the size is for it. And if we execute that, you can see all those come out there. And the only other thing I could think of is how would you delete a key? You would go in here and go superheroes and delete, and you could pass in whatever would be a matching key, and that's going to delete that for you. And if we wanted to double check that that actually was deleted, come in here, see if the actual value for the size changed, and yes, you can see 5 and 4. So those are all the main things you'd ever want to know about using hashes inside of Ruby. So why don't we go and check out Enumerables. Now, a class that includes the enumerable module is going to gain collection capabilities, sort of like we saw with arrays and hashes. Now let's just come in here and create one. Let's call it menu, and let's say include enumerable, just like this. One requirement, however, is if you're going to inherit this, you're going to have to provide a function that is called each. Now we're going to put inside of here all the different things that we're going to have in this enumerable. So if we have a menu, we're going to have pizza, and you're going to define all these different options by putting yield inside of here for each of the possible options, and salad, and water, and bread. Just keeping it simple. Of course, this is going to end with end, and then the class will end with end. We'll then be able to go menu options and create a new menu just by using new, just like we're used to. We can then cycle through all those by going menu options, and guess what? Each, do, again, just like we've seen many times, temporarily held in item, and we can put puts, and we could have an automated sort of waitress here. Would you like, and then put in an item and put end. There it would go and ask, would you like all the different things on our menu? We could then check to see if we have a pizza, for example. So menu options, go find, and then inside of here, make sure you use curly brackets in this situation. We would say item, and we would check if any of these items is equal to pizza, and if it does find a match, it's going to print that out. We could do all kinds of weird things. Let's say that we wanted to return items that are 5 letters in length. We could come in here and say select, and this is going to cycle through all these different options. So we could say item size less than or equal to 5. Likewise, we could use reject instead of select. Reject, and it's going to reject anything that meets those options. We could also come in and print out the first item we have. We could also come in and print out the first 2 by using take, like this. We could return everything except for the first 2 by using drop. That's not going to affect the enumerable in any way, just going to show those. And onwards, we could also menu options, get the minimum item. We could also get the maximum item, and that's going to depend upon alphabetical order, whether you have numbers or letters or whatever. We're also going to have sorting options, and we could even return every single option in reverse order if we'd like. So go reverse each, just to be kind of silly here. There we go. Execute, and you can see everything prints out there on the screen. So there is pretty much everything you want to know about enumerables, and we're pretty much done. I figure why don't we just cover the file object, because it's very useful. As you saw before, if you want to create a new file that you want to write to, use the file object followed by new, and then you would provide a name that you would like to have assigned to this new file you create. If you want to be able to write to it, just put a W inside of there, and there you go. You have a file you can write to. And if it's not created, it will be created. Then you can just use puts to automatically go in and throw some information into your newly created file. Let's just throw in 3 authors. After you open and put things in the file, you would of course want to close it. If you wanted to output everything that is assigned to this file object, you would just use read and then pass in the file that you wanted to pull information out from. Let's just check to make sure all that works, and yes indeed it does. If you wanted to open a file for appending, just use the file object again, followed by new, and authors out, And then in this situation, instead of a W, if you want to append to the end of the file, you would put an A inside of there. You could then come in and throw in a new author that you may have forgotten. Danielle Steele, for example, and of course close that file again. And then if you wanted to read from this file again just to make sure that it updated, you can see that Danielle Steele is now there. This didn't copy this multiple different times, just shows that way because we have this other read here. And then let's go and create another file equal to file, make sure that's uppercase, new, and let's call this one authors info out, and it's a new file that hasn't been created. Let's make it writable. And in this situation, we're going to put a whole bunch of information in here. So we're going to have the author's name, their language, the type of poetry or types of books they wrote, and the number of items sold on our screen. Close our file. And then let's say we want to cycle through the data to write out sentences based off the data that's stored inside of there. We can go File Open, and then we can type in author info like this. Out, there is the name of our file. Do, we're going to be able to use do again, and we could say each one of those lines is going to be a record. And then we could go record each do. We could have each line of that document go inside of the item here. We could then split each line into 4 parts based off of commas. So we'll say name will be the first one, lang will be the next one, specialty will be the next one, and sales will be the next one, is equal to item. This item represents the whole entire line. And we can say chomp, which means all that information is going to be split based off of commas. And then after we split all that stuff, we could go puts and make some neat things. Let's say name was a, and we could say what type of, make sure you have the curly brace closed there, was a, and we could type in language, author, that, specialized in, and whatever their specialty was, and then say something like they sold over, and whatever the sales were for their books, and then books, and then after that, we want to close this off, and then close this off. And if we save that and jump over here, you're going to see William Shakespeare was an English author who specialized in plays and poetry. They sold over 4 billion books. So there you go, guys. There is a heck of a lot of information about Ruby. Please leave your questions and comments below. Otherwise, till next time.